Hi everybody. I'm going to be exiting out of my little webcam, but I just wanted to say hi and hope everybody's doing well. I miss you all, and we're going to dive right into properties of logs. Get it? See my little log dude over here? It's really excited about him. But hope you're all doing well, and don't make fun of my video too much. Okay, I'm going away now. All right, as I said, we're going to do properties of logarithms. What that means is the same rules that we use for exponents, we use for logarithms. So the next slide has all, maybe that lets me, there we go, has all these properties, and it might look overwhelming, but what I want you to understand is that they're the same properties for exponents. So for instance, let's see how fancy I can be. Woo, laser pointer. Okay. If we look here, we have log with any base. So here they're using A. In our textbook, we use B. But we have two things being multiplied. Well, what we know is when we have exponents that are being multiplied with the same base, we add them. And that's exactly what you do with logs. Same with the natural log. For a quotient, if they're being divided, then we subtract, just like you would with exponents. If you have something to the power, then you multiply the exponent. So you're going to multiply. So what ends up happening is this n comes in front of the log. So what's the exponent comes in front? Same with for natural log. Log and natural log, common log are all being used the same. So what we can do is I'm going to post this image into Google Classroom so you have it as a reference. Next Tuesday, I'm going to outline this in Google Classroom. So it's going to be your quote-unquote chapter 4 test, trying to make it so that it's online. Obviously, I'm not there to prevent you from using your notes or calculator, things like that. So, try to be as honest as possible, but also resourceful. But I'll give you more information as that comes through. When you have a log of a reciprocal, remember a reciprocal is to the -1 power, so it's acting just like your power property, so -1 comes in front. The log of the same base, these are your reciprocal properties we already knew. So these properties we're just going to use when we need to simplify. All right, so let's go on to the next. So here we have our log of a product property. And here again, when you have the same base, you add the exponent. So if we have m times n, oh, the n is missing. Let me put that in there for you. We do log with base b of m plus log with base b of n. So for our first example, we have log with base 7 of x, 10 times x. So we end up with log with base 7 of 10. Hold on. I'm trying so hard, guys. Plus log with base 7 x. The same is true for natural log. So here we have natural log. We know for natural log our base is e, right? And we have 8 times e. So we're going to separate this. We're going to expand, as they say. Natural log 8 plus natural log of e. But now we need to simplify. Natural log of e, we know from our reciprocal properties is, this is where you would all yell out 1. And then that would be your answer. For your quotient property, if you're dividing, right, then we subtract. So with this log with base b of m divided by n, we have log with base b of m minus log with base b. I don't know what's happening to my letter n here. There we go. So example 1, we keep the same base. So log with base 8 of 23. I can write, hold on. 23 minus log base 8 of x. So instead of addition, subtraction because there's division going on. Same with our natural log. So natural log of e to the 5th power minus natural log of 11. And again, we're going to have to simplify. So if we take a look at this guy, natural log of e to the 5th. Now you could use your power property and say 5 times the natural log of e minus the natural log of 11. We know natural log of e is 1, so 5 times 1 is just 5. Or we also know from our properties from the beginning of this chapter that the natural log of e to the 5th would just be 5 because it's of the same base, because natural log has a base of e. All right, power property. I said this before when we introduced those properties, but we're going to take a look. Here is my n power. So I bring it out in front and I multiply. So here, log with base 5 of 7 to the 4th. This exponent is going to come in front. So I end up with 4 times log of 5 with base 5 of 7. So in a simpler way, it would just be 4 log with base 5 of 7. You don't have to space it out as much as I did. So now what's tricky here is to remember that this radical, if I extend it, is, an exponent. So this would actually be the natural log of x to the 1/3 power. Remembering that you bring it down, so I have 1/3 natural log of x. So graphically, that would be a vertical shrink of 1/3. All right. Now, we're going to combine these properties. So I'm going to do these together. Now, in class, I would have let you do these on your own, but since I'm not home with you, I'm going to show you. Feel free to pause the video and try to do it on your own and then see what I've done. It's up to you. Now, as a reminder, when you have log base 10, that is called common log. I feel like Dora the Explorer where I'm like pausing for your input. But yes, this is common log. So I have log of 5, and these are all getting multiplied. That's my ability to make it. So log of 5 plus log x to the 3rd plus log y. Now, if we take a look, I can simplify this, even though I might want to. I know that even though it has a base 10 and 5 is half of 10, it doesn't have a power relationship. What I can simplify is this x to the 3rd. So my final expansion would be log 5 plus 3 log x plus log y. And you can box it like I normally do in lessons. There you go. Here, we got to be a little tricky. So we have natural log of x squared times x plus 2. Now, your distributive property instincts might be saying to you, hey, let me multiply this. You could, but you don't need to because it's just multiplication. It's up to you. It wouldn't be wrong. It just would kind of make more work for yourself. So here I took that radical and I made it to the 1/2 power. So I'm going to first bring it out in front. So 1/2 times this whole thing, natural log, you know how I love my parentheses, x squared times x plus 2. And now we're going to expand this natural log. So I have 1/2 times the natural log. That kind of looks like a weird, but natural log of x squared. Now this is multiplication, so plus natural log of x plus 2. I cannot expand x plus 2 because it's not a power property, it's not a quotient property, it's addition in here. So we just leave like that. Remembering for the graph, that would be shifting it to the left 2 units. This I can, however. So I end up with 1/2 times 2 times the natural log of x plus the natural log of x plus 2. Now your final step is to distribute this 1/2. So 1/2 times 2 is going to give us 1 side of the natural log of x plus 1/2 natural log x plus 2. Now you do not want, I kind of cut off. You do not want to make this now the radical because again, we're trying to expand it. We do simplify when you can, like obviously 1/2 times 2. But when you distribute it here, we're not going to then raise it again because it's kind of condensing. So this would be your final answer. All right, let's take a look here. We have the natural log of e squared natural log of e squared times the square root of y. So always separate your multiplication if you can. So since this is being multiplied, I have the natural log of e squared plus the natural log of square root of y. Now, this we know from previous chapters that this becomes 2. If you look at the previous example I showed you, you could use your power property to say 2 times the natural log of e, but we also know if it has the same base, it's just your exponent. So then I'm going to have plus the natural log of y to the 1/2 power because that's my square root. So then my final answer is 2 plus 1/2 natural log of y, because again this exponent came down in front. Here we are going to use our quotient property. So log of base 6 of x to the 1/3 power, right? This is my 1/3 power, minus, now this whole thing is what we're going to do. Log with base 6, I said 6 and I wrote 3. Log with base 6 of 36 y to the 4th. Now, if you remember, my cardinal rule of honors algebra 2 is forgetting to distribute your negative. So let's first simplify this expression. So using our power property, we're going to bring this in front. So I have 1/3 log base 6 of x minus, now this is whole thing, so we're going to put in parentheses, log of 6 of 36 plus, because it's the quotient, these two things are getting multiplied, log with base 6 of y to the 4th. We should know that we can simplify log with base 6 of 36. So I write the beginning part, log of 1/3 log base 6 of x minus 6 to what power 36 is 2 plus, now I'm going to bring this power down, 4 log 6y. But now don't forget to distribute the negative. So my final answer is 1/3 log with base 6 of x minus 2 minus 4 log 6y. And tomorrow's lesson, we're going to learn how to, if I'm given something crazy like this, how to condense it. So just keep in mind this property right here. That we had to distribute this negative because we divide a whole quotient. So you end up with 2 subtraction symbols, and that ends up getting factored out when we expand. But that's for tomorrow. I hope this video was helpful, and I hope everyone is doing well. And if you have any questions, please email me. Have a good one. This is section 4.3 in your textbook, by the way. All right. Bye, guys.